Aloha, my name is Joel Truesdell and I have the privilege of teaching Hawaiian culture-based chemistry to Hawaiian kids. The method that I've developed actually works K through 12 regardless of discipline, and I want to really illustrate that to you. Traditionally in Hawaiian culture-based learning, 100% of the students would learn. Now that is my goal, is to have in this 100% of my students learn chemistry, and I've been very, very successful at that. Now in the instructional method, what was highlighted was the Poho okai, or the salt drying ponds. And there's a lab that I came up with. And for 1,000 years, the Hawaiians got their salt by taking salt water and drying them in lava ponds that were lined with calcium hydroxide. Now the calcium hydroxide came from taking coral or calcium carbonate, heating it and decomposing it to calcium oxide, hydrating that with water to make the calcium hydroxide to make a paste. The students will be doing that, but in addition to that, they will also be taking the calcium hydroxide. When it was in the lava drying pond, it was harvested with the salt and served as an antacid in the diet. So they're going to be titrating that with HCl. So what ends up happening with the lab is you get 4 out of the 5 basic reaction types. But we don't stop there. I have them gathering data. The mass loss that comes from carbon dioxide when you heat it is going to be used as an inquiry-based assignment in the gas laws. The acid-base reaction that occurs, they're going to be doing that as a titration for both the acid-base unit and also equilibrium. I will have them also take some of the calcium oxide and add it to water to have an inquiry-based assignment for thermodynamics. So essentially what we're doing is we're extending this to many of the major units in chemistry, the single lab. Now, the way Hawaiians learn is very consistent with NGSS. What happens is the students do a lot of investigating, and then do hands-on types of activities once they've built a foundation. And that's the same way that we do it in our class, and the kids love it. Now, in addition to that though, the kids have had to build the procedure, and it's up to 34 steps long for this 2.5-day lab. And so you're going to see with the regular kids in my period 2, my weaker class, you're going to see that class, they're a little bit more unsure than the clips we have at the end of period 5, which is my honors class. Those kids are a little bit more on it. But we've got kids, the period 2, essentially, they're very deficient in algebra. In fact, their pre-test that they had, they only averaged 7.1 out of 15 questions right, or 46%. So I continue in my method is I connect it to the culture, I remediate any weaknesses, and I build their self-confidence, and then you have a fantastic scientist at the end. Now, the kids had to invest the safety concerns for the chemicals involved, and what they came up with was using goggles and using gloves for the handling of the calcium hydroxide. So essentially that was well covered. This one, what you're going to be seeing is these are tools in my toolbox. If you happen to make it out here at the end of January, early February, I would love to show you my entire toolbox, but also see Hawaiian culture-based learning in action, because it's a lot. There's a lot more to it than I think that we can put into a 30-minute video. Mahalo and aloha. On Monday or Tuesday, let's go. Get the glasses on, and let's rock. Are you recording, Wilson? Okay. Well, let's take a look at your procedure. Do you have your procedure? Yeah. You've already done all of that down here. Now, place in a test tube. You didn't record it all. Oh, a spatula full. A spatula full of unheated coral powder. In this case, we're just using a spatula full of the heated stuff. That's fine. Yeah, that's fine. You measure the mass on this. I'm not sure why you were pouring it in there. Well, maybe because they did. But no, the mass and volume are two different things.
Can we use this for the cement thing in the cup?
No, in that. Yes, but you're supposed to. It's probably easier to actually do it in this than in a graduated cylinder.
Don't we need to like measure how much we put in?
By drop wise, you're just counting drops.
Well, this is 5.
Okay, you measure the 5, but then you put it in this, and then you add it drop wise. Because the other thing is, you're supposed to be swirling it. Okay, you're supposed to be shaking it. Because you shake it and then compare it to the color standard. Okay, this guy, you never shook this one up. What does that tell you? Can you explain that?
pH is 5.
It's unheated.
Well, did anybody record the pH?
Yeah. pH is 7.
Okay. And the pH of this one. And what does that tell you?
There's a reaction between the heated and the unheated.
Are we? Explain it. No, go ahead. Explain it.
Okay, so the pH in the heated one went up, or does that down?
Yes. Yes.
Okay, so it goes
Which indicates a
reaction.
chemical reaction. Okay. Thank you.
It's not changing colors. This one turned into the sea.
But what's happened is
It's clear.
you're not done yet. You're not done. You're going to keep adding it. Okay. You're going to keep adding dropwise until you see a chemical change. So thus far you haven't observed it. So you're not done yet.
Mr. Truesdell,
Yeah.
around how much usually drops it takes? We're on like 30 something. You think we did something wrong already?
No, there's no way of knowing.
Bro,
Yeah.
sometimes they react quick.
Because what you did is you added in your material down on the bottom, and people add in different amounts. And our question, now that you got to red, what are you supposed to do at that point?
It's supposed to bring it back. We bring it back, right?
You bring it back. Okay. So you've taken the solution that would occur with respect to the lining of the salt drying pond. You've added HCl to it to get it to be real acidic. Now we're going to bring it back. So what do we now have to add in? And it's right in front of you, Justin.
Universe.
Nope.
HCl.
Nope, you've already had that.
I mean,
The HCl did not turn to red.
Heated coral solution.
The heated coral solution, which is which one?
The CA.
Oh, you gotta change pink first.
The CO.
Okay, so
For this, I don't know what to do.
So have you not started that guy yet?
No,
We just put in the thing, that's all, the green.
We put in the universal indicator.
Okay. And did you do it with the rock one too?
yeah.
Yeah.
Okay. So what does that tell you? Explain your data to me on that.
The pH is higher in one than the other.
Which one?
The heated one.
The heated one. Okay. And that's evidence of
Chemical reaction.
Acidity.
chemical reaction.
Oh.
Now, what does it tell you in your procedure that you're supposed to do? Okay. You,
It says,
Don't you have to like restore it or something? But I don't know how to do that.
well, you got.
says you need
Eventually.
to react 5 milliliters of heated coral solution above with a 0.5 MHCl. Measure the
5
volume.
milliliters?
Of this.
Wait,
What is this solution? What is this solution of?
Unheated. I mean, heated.
Heated.
H2O and the universal. Yeah.
This is the heated coral solution.
Yeah.
And you made up 10 milliliters of it.
Yeah.
Okay? So you take. Okay, Reese, get in your own group, please.
Okay, so what do we do with the rest of this? After we got a reaction.
Did you get your reaction in the coffee cup?
No, we did not. Start that.
Okay.
Where's your paste or that powder?
The paste.
Oh my god.
You're supposed to divide it into two. Half of it goes for this and half of it goes for the paste. I'll have to give you some of the other stuff.
It doesn't need to be in a. We don't need to measure the.
Okay, Justin, Faith and Faith, bring up or get a separate beaker so that I can give you some of the backup. No, I want a beaker. I'm not gonna give you. What are you doing over here?
You're about to add the water.
Did you measure the mass of this guy?
Yes.
It's 3.570 grams.
Okay.
There you go.
Ah, damn.
So if you've got 3 grams, I probably wouldn't do more than definitely not more than 20 milliliters. But whatever you do, you have to record that exact amount. You're gonna need that data for later on.
So, okay, so should we take off this temperature?
Or degrees higher.
Yours got 4 degrees higher.
I don't know, as of right now.
Well, how much should we pour in? How do
You
we
make
know?
sure you're recording it.
Yeah.
Recording it.
Truesdell?
Degrees higher.
How do we know exactly
Okay.
final temperature? When do we stop?
Yeah. Just stop for a second periodically and don't pull it out, and then look at it.
Did it go up?
Yeah. 26 on the dot.
But keep stirring. The reaction may not be complete. Okay.
We'll just put 26 for now. Right here.
Now that temperature change is indicative of
What?
the temperature change indicates what?
That the dust has a high temperature.
No.
Oh, the heat stays in.
No.
Staying in the coral dust.
No.
It's indicating that
So what?
coral adds heat to the ocean.
No.
No, man.
No.
Stirring.
No.
The coral adds heat to the water. It does.
No.
That's why the heat's going up.
No. No. It indicates there's a chemical reaction occurring.
Oh,
But then why didn't you say it?
that's obvious.
It's not. If it was obvious, then you would have said it.
It's so obvious. I just
Coral adds heat to the ocean.
Yes.
No.
I don't know. It makes sense. 'Cause
No.
water.
No.
Coral's hot.
Okay.
Ours is up like 9 degrees.
9 degrees. That's impressive.
Yeah.
That's good. Okay.
29 now?
Yeah, we're at
And the 9 degree.
31.1.
How much did you put in?
Let's just stir it.
We had like 3 point.
No, wait, what? How
We
much?
had-
What?
How many grams?
We put 20. Oh, we put 5 grams. Or
We put
3 point
We put
No, it's going to
3.570
grams.
In how much water?
20 milliliters.
20
Okay.
milliliters.
And the temperature change is indicative of a
Chemical reaction.
Chemical reaction.
chemical reaction. Okay. Very good. Very good.
Okay.
Okay, how are we doing on making the paste?
Oh, we finished.
You already pasted it?
Oh, we did.
Oh,
Never pasted.
Oh, well, we didn't
make
paste
make
it.
sure.
Paste it.
Okay, that looks good. Let's go over and find a rock for you to paste.
So we're done
Okay.
with this experiment.
Yeah. Okay.
Did no one else do this part yet?
No, some of them already did, but they did it on the 2 big rocks over there, and they're getting kind of full.
So some people like share rocks.
Yeah.
I saw a lot of other ones out there using. Okay,
So you go ahead and traditionally you would take it out with your fingers, and then you would nice well. So they were doing a lot more than you guys would do, but we're just giving you the skill, so you know how to do it. Yeah, we have had people in the past that have gone and actually done it down in Poho. The typical way that they would do it, though, is traditionally, we actually have about 4 of these regular lava rock bowls. Okay? And so, in which case, yeah, you could take some salt water home and just leave it sitting there, because if you live like up in Volcano someplace, you carry the water, you put it in, and let it dry there in the bowls.
So am I like filling up this bowl?
You're doing it. Nature is not necessarily real smooth, so outstanding. Are you proud?
Kinda, yeah.
Okay. Very good. So you got your label on it.
I don't know how to put it on. It's not sticking.
Actually, take some tape and go all the way around.
Oh, I tape it to the tape.
Yeah. Yeah, she come, Mackenzie. Okay, let's start down at the end. Let's start having you explain your data. That's better. That we'll go with that. Guys, do you have any theory as to why it's different?
Maybe some of the coral isn't cooked all the way through, so the pH level isn't.
That is exactly right. That's the best answer I've had today, Kylie. Okay, because so what happens then is, that's why we said to use small to medium pieces, right?
Yeah.
You use too big of a piece and the inside is not reacted. When you powder it, now all of a sudden you have a preponderance of unreacted mixed in, which is going to affect the pH.
Okay.
That's very good.
So you want us to take 5 milliliters off the top of it?
Yes.
And react it with hydrochloric acid?
Yes.
Drop by drop.
Yeah, and again, you're going to know the volume, record the volume that you do put in using the graduated cylinder, and then keep track of the drop by drop part. Okay. Very good. Okay, can you explain your data for me? You got it. Hang on, I got it. Kylie and Jordan. Okay? Relative to data.
So this is the unheated coral solution that we mixed in with 5 drops of indicator.
Okay.
It's unheated, which means it's the pH is negative. And then this one is the heated coral solution, and we mixed it with 7 drops of indicator.
Basic.
It's also basic, yeah.
Okay.
And its pH is 10.
Okay.
And then we poured 5 milliliters out of this, and we're going to mix it with hydrochloric acid.
And which one are you going to be adding the hydrochloric acid to?
This one.
Okay. Very good. Okay. Yes, and that actually can go down the sink. It's basically neutral with a little bit of Tums with calcium in it. Okay, guys, I want you to explain to me what you're doing and what your data looks like.
Well,
Okay.
our heated. That's our unheated.
That's unheated.
That's unheated.
Have you done anything to it yet?
Yes.
We put the universal indicator in.
What about this guy?
Yes,
This
we
one
put
is the heated that we put universal indicator
heated
in.
smashed. Yes.
What is
That
this?
was a failure because there was something inside
So it's contaminated.
before or something.
But is this heated?
No, it's unheated.
It's unheated.
Yeah.
Okay.
Blue should not be that big.
I would suggest, and that's the heated.
Yes.
Okay, it's blue. That's good enough.
good enough?
Yeah, that's good enough. So now what's the next step? Well, what do the colors tell you?
These are. They're all basic.
Yeah, they're pretty much basic.
But how basic? You're not giving me complete data.
Yeah, react 5 milliliters.
This one is closer to neutral. I don't know.
Okay. Well, it's up on the board someplace.
Someplace.
Yeah, behind. Could you lead me through your data a little bit? I think you have stuff in here. What is what?
That's the unheated.
We're going to yellow.
Okay.
We have to label it so we know.
Okay, and the pH of that is?
That's a 6. That's 6.
Yeah.
That's 6.
Okay. And how about this guy over here?
We couldn't decide if it was like more of a blue or a green.
It looks more of a blue to me, but. Okay, so, and then what are you going to do?
5 milliliters of the heated coral solution, so this one.
Yeah.
Okay.
And then that was just 2 drops.
0.05
Well, that right there. No, not 7 drops that. You'd be like, look, red. Not 7.
The HCl. So the flask over there, you will take back over there and fill it up with the HCl solution. So you're going to be taking it out of the HCl solution with the HCl barrel pipette. Okay. Now I'll come back and check on your data on that. Okay.
You did a debrief on the Poho lab that you did. It was a 2-day lab. And so let's go over it to make sure that everybody's on the same page. The proper learning is gone on. Anybody would like to comment on the complexity of the lab, especially doing the research to construct the procedures and everything we were doing? Comment. Okay. Derek.
Well, it was the first time I ever worked with anything like this, like chemicals and actually mixing them together to see what would happen to them. So figuring out what to do it correctly was kind of difficult for me, but seeing what would happen was interesting too.
Yeah, thank you. Now let's go back over the steps. The whole purpose of this, or the first purpose of this, we have many purposes here, but the first purpose was to illustrate 4 out of the 5 basic reaction types that we're going to be seeing in Chapter 11. We're not even there yet. And we do it within this entire lab. The first one, and I want you to kind of tell me a little bit about the pieces of evidence. We had our bank over here of different pieces of evidence of a chemical reaction. Who would like to volunteer relative to the first part? We took the coral and we heated it. Vince.
The effect of heating the coral was mass loss and the brittleness change.
You got it. So essentially we had 2 pieces of evidence that a reaction occurred. Okay, the next one. We took the result of that first one, calcium oxide, we added water and universal indicator, and compared it against stuff that had not been heated. Okay? So, yes, Vic.
So the color change and also the color change and also the pH change.
Okay. The color change and the pH change of the heated versus the unheated was evidence of a chemical reaction. And finally, what we're doing down here is we especially got into the next part, which we're going to talk about down here, where we're taking and gaining data to be able to do all these advanced assignments for the units in the second semester. The calcium oxide and the water that went into the coffee cup. What evidence do we have in that? Yes, temperature change? Temperature change. Okay. Was there any other one that we actually tested in there for it? From the test bank? Just checking. No. But that was enough. We did have a reaction. Energy was given off. The temperature went up, and heat was given off. Okay. Now, the Poho Pa'akai, when the salt is harvested, it was taken back, and people would use the salt in their food, but some of the calcium hydroxide would make it into their stomach and react with this stomach acid, the hydrochloric acid. Okay, so this next one, what evidence did we have when we were doing that? Yes, Reese?
Color and pH change.
Color and pH change. Okay. Were there any other ones you can think of? No. But we did follow that. Okay. Okay. Anybody who would like to comment? Have somebody else comment on the overall difficulty of the lab. Was it easy? Was it medium? Was it hard, and why?
I think that it was kind of hard because the extra mass of how much powder you had, like the coral, how much coral powder you had was it wasn't enough for the coffee cup experiment. So yeah, that part was difficult. Yeah.
So part of the difficulty was really not able initially to be able to plan for how much of the calcium oxide that you would need throughout the entire experiment.
I think as long as you have like a really easy to follow procedure, then you can do it. Because I missed writing a few steps, and if you like skip one, you have to go back and you have to do it again, or your results won't be accurate.
I think by dividing the jobs between the group, it was easier so that,
it shared an equal amount of work, and it made it faster to finish.
And a great lesson for working in science, because if everybody just sits there and watches somebody else do the work, progress only goes at the rate of that one person as opposed to the 3 times the rate for the 3 people in the group. Okay? Any other comments on the difficulty? My comment was, that's as hard of a 10th grade lab as I've ever done. Okay, period. And you guys did it. And you did a really good job, all the way from the initial planning to all the way to the follow-through. Okay? And that's basically, if you came in here thinking that you're really not a rock star in science, you've elevated your game. Okay? Doing stuff like that. And we're going to continue to do that over the course of the year. Okay, any comment on the overall coolness?
Well, already the lab caught me when we started using heat to deal with seeing how the coral would react to being heated for a set amount of time. And then also when we were looking at the changing pH, it was interesting just to see the colors to actually see what was changing.
Okay. Yes, Kate.
So when I mixed the heated powder with the water in the coffee cup, I think that was really cool when the temperature started to change, because I never really thought that the temperature would change of the water.
So it was cool to see the unexpected. Yeah.
Cherry.
Good. Anybody else? Yes, Sarah.
I thought it was really cool because we use a lot of different tools than we usually would in any other lab, like the burner and like the universal indicator thing.
Mm-hmm. So it's very cool to be exposed to new materials that you can use. Okay. Anybody else? Yes. No. Okay. One of the biggest things in this is the data. We have to preserve your data, because the data that was used, where the temperature went up, that data is going to be used to introduce you to thermodynamics. The mass loss of CO2 gas is going to be used to introduce you to gas laws. The titration, essentially it's called, which you haven't even, and I like some of the questions. People were asking about pH. You were asking about these future things because you were gathering data for topics that we haven't even covered yet. Now, essentially this data here, the calcium hydroxide with the HCl, is going to be used for your introduction to acid-base, and when you went back and forth, it's going to be used for introduction to equilibrium. It's called the Chatelier's principle. So this one lab leads you into 4 of the major topics in chemistry in the 2nd semester. Is that cool or what?
That's
it is. So you're going to be, it's not just like giving you some problems that don't mean anything. It's giving you problems that connect not only to the culture and all the chemistry that is in a salt drying pond, but it's also your data, not somebody else. Okay?
Yep.
Okay. I think so.
Okay.
How much do you guys love culture-based chemistry? It's awesome.
I love it.
I like it.